Hi everyone, so this is a quick video on how to do circuit diagrams. First off, we're going to start with a couple of the symbols, and I guess I should explain what a circuit diagram is. So a circuit diagram is just explaining all of the connections in your circuit. So if I wanted to look at someone else's circuit diagram, I could make those same connections. Doesn't necessarily talk about the placement of any of your components on like a breadboard or something like that. It's just saying what is connected to what. Okay, so let's start with a good symbol for an Arduino. So I'm just going to draw a box here, and then I'm going to draw a little infinity symbol. And now I'm drawing that infinity symbol because Arduino actually uses this infinity symbol as one of their logos. So especially in this class, you can just draw this infinity symbol, and we're going to know that you're talking about an Arduino. And then if I wanted to designate a pin, I can say like pin 4 is right here, or maybe I have ground right here, something like that. So this is a good symbol for an Arduino. Okay, so now let's talk about some of the more common symbols that you're going to be using in this class. And you can look up tables of different kinds of symbols in case you're using some like new thing that we're not using. And yeah, so we're going to talk about just some of the basic ones. So let's talk about power. So I'm going to draw something like this. And you'll notice I have a longer line here and a shorter line here. I'll talk about that in just a second. So then I'm going to draw a wire coming out there and a wire coming out here. So this longer line is my high potential or my high voltage side. And a good practice is to label this with whatever voltage you're using. So in our Arduino, we're usually using 5 volts, so I'm going to say 5 volts. And this tells me that I have 5 volts coming from this side, the big side, and then on this other side, it has to be 0. So this is 0 volts, but you don't need to label the 0 volts. We're going to know that this is 0 volts. And then let's talk about maybe a resistor. So a resistor looks like this, just a zigzaggy line, and it's a good idea to label all of your resistors. So I'm going to say that this one is a 100 ohm resistor, and I'm going to put this omega symbol here, and that just stands for ohms. It's the measurement of how resistive this resistor is. And yeah, so it's a good idea to label that. Another thing that we're working with is an LED, or a light-emitting diode. So if I were just to draw something like this, with the arrow and then a flat spot, and I just left it like that, that's just a regular diode. And that means that it only allows current to flow in one direction. It allows current to flow in the direction of this little arrow here, but it doesn't necessarily emit light. So if I want to designate this as a light-emitting diode, I need to draw a couple little arrows out there, and that lets the person reading the schematic know, hey, this is not just a regular diode, it is a light-emitting diode. And now that light can be something like red, green, blue, so it can be something that we can see, or it can be something like infrared. Infrared, like if you see that little bulb on the end of your TV remote, that's an infrared diode. And so we can't see that with our eyes, but if you actually look at it using your phone camera, then your phone camera can actually detect that wavelength of light and shows it as kind of this purplish light. Okay, so that's the symbol for a light-emitting diode. Now maybe we'll talk about something like a switch. So there are two main kinds of switches that we're going to be using, and so I'll draw both of them. So this is a latching switch, and then we have a momentary switch. And a momentary switch looks like this. You can also call this a push button. It's the same thing. A momentary switch, a push button. Buttons are switches, and yeah. So this is kind of like the symbol for maybe a light switch or something. Something that you would turn on or turn off, and you wouldn't have to keep holding it for it to stay on or off. Now, while this is activated or engaged, say I flip a light switch, then it just looks like a wire. So this is like a little hinge that comes down like that. And when I turn that hinge down like this, it just looks like a wire. Okay, so this is what a push button is, and a push button or a momentary switch is something that you push, and then when you release it, it goes back into its normal state. So something like this is a push button switch, and when it is pressed down, it kind of looks like this maybe. If you just imagine these are actually contacting here, and then we have that little plunger right there. So when it's not pushed down, current can't flow because it doesn't have anywhere to go from the end of this piece of metal there. But when it is pushed down and these pieces of metal are contacting, it can go up through that metal and then across. And so that's why this works as essentially a switch. Now, there are a couple of different ways to designate these. There is normally open and normally closed. And sometimes it might be important to say something like NO, meaning that this is a normally open switch. And that means if you aren't pressing it, then it's not letting current flow. Normally open means that it is an open circuit. Now, normally closed, NC, means that it allows current to go through it, and actually there's a different symbol for a normally closed switch. This is just a normally open switch that's been pushed. But a normally closed switch looks something more like this. So now we have the plunger on the other side, and then when I do push down on it, then it would look something like this. Right? So now when I am pushing it, it's breaking the connection. And that is a normally closed switch. Right now we're just dealing with normally open switches, so you probably don't need to designate this as normally open if you don't want to. Just draw a symbol like this, and that's going to let us know that that is a normally open switch. Okay, so now let's get into a couple of different ways to draw our circuit diagrams. So I'm going to call these, there are two main methods for doing this, and I'm going to call these two methods, we're going to call one the loop method, and the other one we're going to call the line method. Let me see if I can't move this around here. Okay, line method. Loop method and line method. Awesome. Okay. So first, of course, we need a power source. So I'm going to say, all right, so I have this power source here. Awesome. Just like what we saw up above. I'm going to designate this power source as a 5-volt power source. And then I can start connecting some things to it. So I'm going to go over here. I'm going to draw a little node. Nodes are really important, and I'll talk about that in a minute. I'm going to draw a node, and then maybe I need a resistor. And then I'll draw another node to designate that this resistor is one component. And then maybe I'll go into, say, something like a switch. And then I'll go over here, and we're going to go into an LED, and I need to designate this as an actual LED, a light-emitting diode, not just a regular diode. Cool. And you'll notice I put these little dots here, and that is called a node, and these are really important to designate what is one specific component. It really helps us to visually see that, hey, the thing in between these two nodes is a single resistor, or the thing between these two nodes is a switch. And it also helps us to tell where connections are being made and where they're not being made. One more thing that I might want to do on this is label my resistor. So I'm going to say 100 ohm resistor. Now this could be a 10 kilo ohm resistor or a mega ohm resistor. It just depends on what your load or your LED, whatever is using up some of that energy, what that needs. So we can do the calculations for that, and we might cover that in a little bit, but not in this video. Okay, so this is the loop method, where I'm drawing a loop. Now we're going to talk about the line method. Okay, so line method, I'm going to draw that exact same thing here. So we're going to draw a 5-volt power source, a 100 ohm resistor, a switch, and then a light emitting diode. And the kind of best practice for this is to draw it from high potential going downward into low potential. So I'm going to say 5 volts here, and that is my power source in this case. And then we're going to go down into my resistor, and I need to make sure that I have my nodes here. I'm going to label this resistor 100 ohms. And then continue moving down, we have a switch. So I'm going to put my switch here, make sure I've got that node, and then that node attaches to my LED, and then that LED attaches to ground. Now this is the symbol for ground. There are many different kinds of symbols for ground. Some of them just look like a flat line, but for the sake of this class, it's going to be easiest for us if you label them kind of like this. So you have higher potential here, lower potential there. We're just kind of labeling this as the end point for our circuit, for that specific part of our circuit. So that is our ground symbol. All right, need to make sure that this is a light emitting diode. Awesome, I have my resistor labeled. I have my diode as a light emitting diode. I have 5 volts. I have ground. So you can see this circuit is complete. So that's the line method and the loop method. And these are both equally useful in terms of this class, most likely. Something that you might consider is kind of pairing these together. So maybe if you have a really complicated circuit, you have, let's say I'm going to get an Arduino here. I'm going to label this as an Arduino, and I have like pin 4 and 5 and 6 and 7, and all of these are going out to different places. But maybe I have, you know, I have so much stuff connected over here that it's just going to make a mess if I try and wedge 4 in there somewhere. So instead of just specifically doing 4, if you wanted to, on like a little box on the side of your diagram, you could do something like this. And you could show us, you know, make a little box, and then you could say pin 4, maybe label it D4 for digital pin 4, and then you attach it to something, and make sure you've got your nodes in there. We're going to just say that this is a 100 ohm resistor, and then I've got it going into a diode. And then that diode goes into ground. So maybe make this box a little bit bigger. Make this an LED. And then send it to my ground pin. And this might be useful if you're getting really complicated, but for this class, unless you have a really complicated schematic, we'd prefer that you choose one of these methods for your diagrams and stick with it. If you absolutely need to, and like I said, you have a million things coming out of your circuit, and you just don't really have room to make it very readable, then maybe you want to include something like this over on the side saying, hey, I also have digital pin 4 connected to this thing, or whatever pin you need to get connected. One last thing, how do we tell people, like, hey, you know, maybe these wires are crossing, but they aren't actually connected, or are they connected? Who knows? So that's why nodes are really important. If I put a node here, then it's obvious, well, these wires are all connected to each other. They all are touching each other. A good way to, or there are two main ways to say that they aren't touching each other. One of them is if you're really good at using this node notation and like really labeling everything that is connected to another thing, then you should be fine just to cross things like this, and then we know that they're not connected, or we assume that they're not connected. So you need to understand that if you're using nodes, which you should be, and you draw something like this, then we're going to assume that it is not connected. If you want to make it explicitly obvious that something isn't connected, then you can do something like this, and then instead of having it go directly over, make a little like jump like that. And that's going to tell us that this wire here is separate from this wire. All right, hopefully that is a quick clarification on how to do some circuit diagrams. Let me know if you guys have any issues or run into any problems. I'm happy to look over circuit diagrams and help critique them and help you to make them as clear and concise as possible. And that is the name of the game of circuit diagrams. I should be able to pick up your circuit diagram, and after looking at it for a little bit, I should be able to reproduce it on my own breadboard. Not necessarily in the same placement, like maybe I'm not putting my LED in the exact same row and column on the breadboard, but maybe, I mean, as long as I can get the actual connections and replicate the circuit itself, I should be good. And that's all that circuit diagrams are doing. They're telling us what is connected to what, not necessarily what is placed where. All right. Again, let me know if you have any questions. I am happy to help.